example. And so I thought what we could do is we could like go over it, like see what it's like. So I was thinking we could have the layout like this. Then maybe like this. How do I make this smaller? Is this clear? All right, great. So let's see here. So like I said, this story is called Kubernetes by example. And so they start off by saying, so a pod is a collection of containers sharing a network, and they act as a basic unit of deployment in Kubernetes. Let's make the font a bit bigger. Help, zoom, view, zoom in. Why did it make the monitor big? Why did it get bigger? Okay. So here, and then let's make this a bit bigger as well. Right, so a pod is a collection, so they share a network, and all containers in a pod are scheduled on the same node to launch a pod using the container image, etc., and exposing HTTP API on port 9876 do this. Okay, so kubectl I already downloaded, so I think this stands for Kubernetes control, and it has a whole bunch of stuff, sort of the same way Docker does. And so if you do this, let's see, the connection to server was refused. Did you specify the right host or port? Okay, though this makes things a bit complicated, right? Maybe I should pick a different port. If I just do this, does it work? So if I say port equals 999. Okay, well, first step isn't working. Let's see what's going on. Copy. Oh, okay. First question, sorry. Your cubic config isn't right. Make sure your config is set to the project. When I run gcloud, why do I care about gcloud? Okay. Kubernetes. kubectl footnotes. So let's see. So echo cubic config. kubeadmin. Okay, well, none of these commands seem to be installed. Failing kubelet server. Okay, install Linux, fine. If you're intending to run a Kubernetes cluster on your laptop, you'll need to install a tool like Minikube to be installed first. Does this mean we need to get an AWS machine first? Is this what this is about? Okay, so we're on Linux, and then we are on... Which architecture are we on? How to print architecture. Linux. uname.m. Okay, stable binary download. This is all good. So let's get this. So whatever Minikube is, it looks like a way to do this stuff locally. Let me check. Okay, start your cluster. So mini cube starts. Okay, they made it very cute, I guess. Okay, cool, something's happening. Let's quickly check. So it's a local Kubernetes, making it easy to learn and develop for Kubernetes. All you need is a Docker or virtual machine, and then you can just say Minikube start. Okay, great. So they're creating a Docker container with 2 CPUs and 8 gigs of RAM. Okay. Well, what do you all think about this trend of making like CLIs cute? You know, with like a tractor, building base image, the stars and the whale. I guess like no Docker it does use a whale. Okay, Kube. CL is now configured to use the Minikube cluster and default namespace by default. Okay, so if I start my cluster, if I say Minikube start, what happens? Okay, so they're saying, so interact with it. Okay, so get PO, I'm assuming that's get pods. What does A mean? Deploy application. Okay, let's see what this is like. So create a deployment called hello minikube, and then this is the image. So it did create it. And then expose deployment on port 8080. I see, okay. Okay, great, it's exposed. Okay, great, so it is showing it. So we do have a service called hello minikube of type node port. And this is the cluster. I mean, I'm just saying, what happens if I say curl or yeah, ping 10.100.71.127. Maybe we can do a different layout from usual. Let me do this. New glasses? No, these are the same glasses. I just got a big haircut. Okay, this is better. Can we see like this? It was a very long haircut, by the way. The guy was like so careful. You know, it's like massage and, you know, I don't know, it's like 10 different kinds of creams and stuff. It was very involved. Alright, so let's go back and see if this looks better. Okay, yikes, exactly. So, I mean, we have to do it at some point, right? I think I'm getting a bit annoyed at my lack of domain knowledge here. So let's just learn the basics. Like I think for me, learning the Docker, like the basics of Docker, were actually really helpful. Even if like at this point, I'm just like, you know, I don't know, like all you need is a good bash script. But whatever. So we discovered this thing called Minikube that lets you run services locally. Okay, so then we can say Minikube service hello Minikube. Okay. Opening existing default browser application. Oh, so this is the URL because it was on a specific, because we did a ping without a specific port. All right, so if we just go to this URL, I guess. Headers received and, you know, something about Apple WebKit. Okay, very cool. How do you zoom in here? Okay. Or we could use kubectl to forward the port. What is the difference between Docker and K8? I think they're not... so they're not competitors, but if you want to manage a cluster, so basically many Docker containers, you would use something like Kubernetes. And the idea, so for things like scalable, distributed training, etc., like this is probably the way to go. I would say it's only a lot less popular than Docker because it's more Docker's a more foundational technology, I guess. But if you do sort of want to deploy stuff and you don't have the luxury of having, I don't know, let's say the Facebook infra, this is where I see this coming in, and I'm just disappointed by like my lack of depth of knowledge in it. So I just want to know just like a bit to be dangerous. Okay, so you can have a load balancer deployment, a node port. What's a node port? Node port. Okay, so there's a few service types. So cluster IP exposes service on a cluster internal IP, makes the service only reachable from within the cluster. A node port exposes the service on each node IPs as a static port to which the node port service routes. You'll be able to contact the node service port from outside the cluster by requesting the node IP node port. Does that work? I mean, pseudomaze, if you go to this URL, does it do anything? I'm assuming probably not, but I'm just curious. That'd be kind of amazing actually if it did, but I would be super shocked. Just let me know. Okay, so because that way I don't fully understand the difference between a cluster IP and a node port. And then a load balancer, the service externally using a cloud provider's load balancer. Okay, great. So a load balancer is just a way of interacting with... yes. Oh, sorry. Let me remove my mouse. Yeah, sorry about that. And then an external name, it maps the service to the context field, example foo.bar example, by returning a CNAME record of this value. No proxying of any kind is required. It is loading. Oh, interesting. Okay, well, let's see. Okay, so the tutorial I found was this one. So where was it? So okay, now we have Minikube working. So the tutorial I wanted to go over doesn't present anything. Yeah, that's what I figured. Um, it's called Kubernetes by example. So for example, here they're saying, okay, well, we want to launch this pod. Okay, so it was created. And then the backend that it's using is Minikube, right? And so now we want to see, does it run? So we run kubecontrol, control, get pods. Okay, and now we see this thing, right? It's called size, whatever that means. Okay, and we're gonna see a status for it, right? So we have this thing that's already running, and then this thing. Oh, yeah, so Docker does the same thing. So now container creating. Okay, it's still creating. Okay, now it's running. So it took 30 seconds for it to load. Okay, so the container happens to include a copy of curl, which provides an additional way to verify that the primary web service process is responding over the local net at least, right? So let's see. So kuba exec size t curl s localhost info. So what about if I say exec t and then I want to say name or service line. That's what I figure. I mean, like there has to be something that says like deploy or something, because maybe this is only accessible to my local network. Regardless, like I'm curious. Like here, for example, we're curling from within the pod, but then let's say I want to do something like, for example, kube ctl exec size -t, and then the command I want to run is shell. What happens? Okay, nothing. Now if I want to say echo 1, okay, it does echo 2, echo 3, echo 4. Okay, so this works, and you know, I guess we just have to trust me that this is running on the. Maybe no, we should do something like ls, right? It's more interesting. Okay, great. So yeah, so maybe now we can do cat requirements.txt. Okay, this is getting a bit more interesting, right? So we can actually run commands like the same way like we can in Docker. And then natively we have this thing called requirements.txt. We have, I guess we're going to have a simple service. Simple service.py. And what does this service do? Okay, yeah, so we're going to be clever, and then we're going to redirect this to a local file called simple service.py. And then I'm going to open this up in just VS Code. All right, so I think Tornado was some sort of multi-processing library. And then, okay, you're getting a getenv. I'm surprised, by the way, I learned of getenv very recently. Like, I feel embarrassed about it. But it's like it's really practical, actually. It's instead of doing these weird shell scripts, you could just have like really good Python scripts. Also, how come VS Code and Python looks so much nicer on Linux than on Mac? Okay, so it's like a health serving has been invoked, info. Is this like a video game? Okay, and then there's 4 endpoints that they're exposing. Endpoint, health, info, env. The app listens on port on localhost. And then it does something like, okay, sure. Let's go back here. So let's say, what is endpoint 0? Endpoint 0. Okay, and then I'm imagining health here. So each endpoint looks like its own class with a get function. And each get function has a try except loop where it logs something, it sets some header, and then it writes some JSON. That's kind of cool. Okay. Have y'all used Tornado instead of like I've only ever used like Flask and Django a bit. Tornado, Python. So it's an async networking library originally developed at FriendFeed. It can scale to tens of thousands of open connection, making it ideal for long polling WebSockets and other applications that require a long-lived connection to each user. Fast API is love. Yeah, it does seem like one of those APIs that like everyone who's tried it loves it. Okay, so from within the cluster, this pod will also be directly accessible via its associated pod IP. So if I want to say, so here, describe pod size. Okay, so then if you say describe pod size, it's going to give this fairly long description, it looks like. Let's just read it again. So there's a namespace, a start time, some IP. Okay, and then it has like a container with an ID. And then like a port, host port, how many times it's been restarted. That's kind of interesting, actually. Its type, it's whether it's initialized, ready, pod scheduled, okay. And then the volume that it has. Wow, epic sneeze. Okay, this is kind of cool, actually. Oh, and it has all the events too. Created container size, and then this is kind of interesting, actually. I guess, yeah, because it's not gonna fail locally, right? It needs a good way to log stuff. Okay, what is all this? So export K8 API. Okay. What happens if I say echo? Okay, so it's Minikube, and then export. This thing is worrying me, actually. I feel this is going to break stuff. I'm going to skip this. Delete. What do you mean it's not there? I can see it. Okay, so you can also create a pod from a manifest file. In this case, the pod is running already known simple service image from above along with a generic CentOS container. Okay, so for example, here, this is like, okay, so we have this thing. That's, again, the simple service. And it, has a shell, a CentOS, and then the commands that it needs to run is bin bash. What does -c do? Name 2 containers. Okay. Let's do this. Pod 2 containers created. Okay. Okay, 2 containers was created. So let me delete the pod. So I'm going to say kubectl delete pod deployment of this guy. kubectl delete pod deployment. No deployment, okay, but then if I say kubectl get pods, it's still there. Oh, and it also restarted it for some reason. Okay, what's also interesting here, so the 2 containers thing, it is actually showing like a status of 2 here, right? So back to the, if we were to look at the YAML file again, where does it say that there's 2 containers? Oh yeah, so there are 2. So here, there's this guy, and then there's this guy. And so this is the simple service, and then this is just another service that does bin bash -c. So what happens if I'm gonna try this myself. So I'm gonna say bash.c sleep 1000 bash man bash. The first argument is assigned to 0, and any remaining arguments are assigned to the positional parameters. Okay. So if I say bash c sleep, do I need to say this, for example? Sleep 1000. Okay, I hope this doesn't sleep for and if I say bash.c sleep 1, then echo, sorry, I'm going to say echo 5. Oh, I see. So it's like yeah, sure. So you can just like run programs by passing in a string. Okay, that's fine. So we're gonna have two containers. One of them is gonna be running the simple service.py on this port, and then the other is just a shell program with CentOS doing this thing. Okay, that's all Gucci. So containers that share a pod are able to communicate using local networking. So it demonstrates how to exec into a sidecar shell container to access and inspect the size container via a local host. So if I run this, so I'm going to exec two containers, and then I'm going to pass in a T. I think this means run a command. So in Docker, it's IT. So I forget what the T stands for, but then, okay, we're going to say curl S and then curl S to localhost info. And so here it's returning how to exec into a sidecar shell container to access and inspect the size container via localhost. Okay, so, but nowhere are we saying size, right? Like that's the thing. So here, 9876.76 is exposed. But this doesn't have a port, right? So how do I know if I'm running from here, or am I running in like a third place? Like, is that how that works? Okay. So define the resources attribute to influence how much CPU and RAM a container in a pod can use. This example uses 64 megabytes of RAM and 0.5 CPUs. Okay, so you can say here's a limit of 764 MI. You know, why this wouldn't be MB? No one, you know, and what you have, like 500 million CPUs. Okay. But this is interesting. So let's say I'm gonna create this pod. And then I'm gonna describe it. And it should say somewhere, yeah, the limits. Okay. So far, this feels very similar to Docker, at least this sort of setup. Because I believe in Docker, I saw that you could limit constraints as well. I think we had something like it here. In TorchServe. Docker, I think it was here. Yeah, there was. So ulimit memlock and ulimit stack. What does ulimit mean? Maximum locked in memory address. Oh, so this is the Linux stack size. And the shared memory size. Let's see, so Docker limit number of CPUs. Oh, exact same thing. You also can say set a limit. And then, yeah, I guess the visual experience, you could do the same thing. This is all very cool. So I guess what you could also do is, if you want to be fancy, then say grep CPU, right? And it shows you the limit. You can also grep memory, also shows you how this works. Right, I just realized that you have a long weekend. Friday was off and Monday's off. Yeah, like exactly. Like it's why I'm. I think I've been on stream so much. Yeah, so tomorrow is gonna be the episode with Christian. So we're gonna be going over tweaks, and then Monday, I'm gonna go to the zoo because the zoo's awesome, and then probably just write in the afternoon. Yeah, probably not gonna stream the zoo though. I don't think I'm ready to be that kind of streamer. Okay, so we did the basics. So labels are a mechanism to organize Kubernetes projects. So a label is a key value pair with certain restrictions concerning length and allowed values. So you can use it, say department X owns that prod. So okay, so what is this thing? So it just says there's a label called env. Okay, so it's a key value store. So okay, this is the development branch for this team, for this org, and you put all sorts of metadata that you care about. So that's great. So what we're gonna do is this, just run it. And then I'm gonna say kubectl show labels. Then where are the labels? Oh yeah, here it is, end of development, okay. So then what I'm gonna do is maybe I'll say wget, oh no. I guess this means you could have multiple labels. So if I wget this, no, not on wget this, so copy link, wget, paste. Right, and then I'm gonna code pod YAML. And then I'm gonna create another label, which is owner, mark, team, PyTorch, quarter, H2, right? Like, does this work? Okay, so let's say I do that, and then I want to say kubectl apply -f. So kubectl apply -f pod YAML. Okay, so then if I go to get pod show labels, oh yeah, they did all show up too. Right. So there's the end development, owner mark. Okay, so this is great actually. So I guess this comes more into the production stuff. But typically I have seen lots of code bases do something like this where you'll have like a class to do this, but here I guess it's just a YAML. So makes sense to me so far. Okay, now let's keep going. Okay, you can also add a label. That's great. Okay, then you can search on those labels. Also great. Okay, cool. So now I think we get to the interesting stuff, right? Which is deployments, port forwarding, all that stuff. So deployment is a supervisor for pods, giving you fine-grained control over how and when a new pod version is rolled out, as well as rolled back to a previous state. So let's create a deployment called size deploy that produces 2 replicas of a pod, as well as a replica. 2 replicas of a pod and a replica set. What's a replica set? HTTPS. Okay. So we're saying, okay, we have this thing, it's a deployment, and it's called size deploy. So I would imagine metadata to me seems kind of like labels. What's the difference? And then you have replicas with what's a selector. I don't know what a template is either. But then you see, so there's a spec, and then there's sort of a nested spec inside of it. So in this nested spec, we have a container with. In this nested spec, we have 2 containers. One called size, exposed on this port, and then the other is just called simple service version with a value. Okay, whatever value is. So sorry, I'm just confused because I'm thinking is stuff like value like Kubernetes stuff, or is that just sort of like a label that can be anything? Okay. So generally, I think though one thing I find interesting here is that if you want to deploy something, you ideally want to have 3 deployments because that can guarantee you can recover from failures, Because if you have two, you don't know which one's right. Right, so you're never really sure. But with three, like let's say there's one that fails, then you know that the other two are right. So you know that's what I should be rolling back to. Okay, so let's do this. So we're gonna apply the spec. So we have size deploy that was created, and we can look at the deployment as well as the replica set using the get sub command. So if I say paste, so where is it? So yeah, so we have this replica set dot apps with hello minikube, replica sets app size deploy. How do I clean everything? Sorry. kubectl brune all brune. kubectl apply brune. Dot f kubectl brune. Okay, something about those delete commands weren't working earlier, because like here I'm getting a bit confused about what is. Yeah, so here, for example, well, we have hello minikube. So I mean, we know it's the new stuff, right? So it's the stuff that's from 94 seconds ago. So we have this replica set where we desire two, we have two, and we have two ready. Whatever current already means, who knows. And then we have size deploy, also the same. And then we have pod size deploy. So this was in the... Was this here somewhere? Size deploy. Yeah, so this was the name of the deployment. And so they're all prefixed by pod. Oh, I see. Oh, I see. Sorry. So these are each something else, right? So you have the pod. And then the actual deployment, like sort of the app that you can use. The pod is the group of containers. Then you have the app. So what's a replica set exactly? Replica set Kubernetes. So it's to maintain a stable set of replica pods running at any given time, such as it is used to guarantee the availability of a specific number of identical pods. Right, so that means that if you go here and I change this to 12 replicas or 3 replicas, then that's gonna be closer to what I guess a real deployment may look like. Okay, so they show us how these look. And then the size containers running in the pods are configured to return the version 0.9. So let's verify this from within the cluster. By using curl. Okay, you'll need to replace pod name with the generated name of one of your pods. Okay, so I'm going to say kube ctl exec, and then let's say this. So remember, there's 2 pods in the replica set, and then we're going to run -g. That means we want to run something, and then curl, and then we're going to curl localhost for some of its info. And then 9876 info. Okay, and it returned the host and it returned the version. Okay, so that seems to have worked. What happens if we try another command? So if I just try -t and then I say ls. Okay, so it's the same file. Actually, I'm curious what the Docker file looks like. Got Docker file. Okay, yeah, so this helps actually, because this tells us that we're really just going to be running the simple service file, because that's what that command means. And then this is just giving us the Python version 2.7 for whatever reason. And then we're going to be running a simple service. And then actually, if you look at simple service again, what does it do actually? So this is a simple service in version v listening to version port. Okay, so where's version set? Version seems to be like an OS variable. With the OS environment, simple service version 0.5.0. Okay. Okay, good. Okay, so now that they're saying we want to update the version. So we see version, where was it? So yeah, so we saw version 0.9 here, right? If we change that version and updated deployment, so we have D10. And then if we run kubectl get pods. Okay, so it shows us that we're terminating these old, so we terminated the old pods. Sorry, the old deployments. No, the old pods. Sorry, I keep getting confused with nomenclature. And then we created two new ones. They have the same name, but I guess this is sort of the specific replica set. Yeah, so I think if we also do like replica set, we should see the same thing. Yeah, you see, so this was created 39 seconds ago, and this thing was around 6 minutes ago, and it's gone. And then we want to verify that the new version actually works. So kubectl exec, and then size, copy paste this. -t and curl -s 127.0.0.1 port 9876 info. No server of this name. Oh, because I wanted the pod, not the replica set. So let me do that again. Okay, they're gonna make me copy this by hand. So yeah, so let's say it's size deploy 6. This is so cringe. Age 5 minutes. Size deploy 747 848 CD 97 4D GBR. Okay, I'm pretty sure it works. I'm still doing some stupid typo somewhere. Size deploy -7 8 747 848 CD 97 4D GBR. Okay, well, whatever the issue is, I think is fine. Actually, oh, interesting. I like this idea of a rollout history. Let's see this. So there's a revision. Okay, 1 and 2. Okay. And if there's a problem, you can say kubectl undo this deployment to revision 1. I see. And then if I say rollout history. Wait, what does this mean exactly? Like, I would have expected it to show 1 and then at least tell me, like, this is what was done. But, you know, just saying there was a change, I guess, isn't useful. I'm probably missing something simple here. Okay, regardless, I think let's clean up. Okay, so destroy labels X. Delete pod label X. Okay. kubectl delete all pods. kubectl delete all pods. Okay, that's good. So then kubectl delete all deployments. Oh, dash all deployments and replica sets. Okay, that's cool. Okay, so we figured out how to do a rollback. We figured out how to do a replica set so we can have like basically multiple copies of a system running at once. And what else can we do? Okay, service. So service is an abstraction for pods, providing a stable so-called virtual IP address. While pods may come and go with their IP addresses, a service allows clients to reliably connect to the containers running in the pod using the virtual IP. So it's not an actual IP address, but its purpose is to purely forward traffic to one or more pods. So keeping the mapping between the VIP and the pods up to date is the job of kubeproxy, a process that runs on every node which queries the API server to learn about new services in the cluster. So let's create a new pod supervised by a replication controller and a server along with it. Okay, so it looks like this is our replication controller. And then this is our SVC. What's a service? Okay, let's take a quick look at these guys. So this is called a replication controller. It has a single replica and it selects app size, and then it has some name and then some label. And then the spec is a container, and it's the simple service image again that runs the Python app. Okay. And then this thing, which is, it has, oh, so it forwards from this port to that port, I guess. Port 80 to the actual target port of the app. I would imagine that's what that does. So verify that the pod is running. Okay, great. The pod is running. So a new pod should be generated each time this example is run. So make sure to include your own pod name when running the following examples. So it should be kubectl describe pod, and then r size, rc size, and then bwlv. So you can, from within the cluster, access the pod directly via its assigned IP. Okay, sure. The IPs are going to change, so this doesn't matter too much. Get service. Okay, so we have a service called simple service. Oh, that's the cluster IP service. I think, so this helps. Like, I guess the cluster IP will be probably helpfully managed by cloud providers, I would imagine. So now let's add a second pod and scale up the request controller. Is that what it is? Replica controller, sorry. So it was scaled. Wait for both pods to report they are in the running state. Okay, I see, yeah. So this was scaled. So now if I scale it to, I don't know, 20. In this case, there's one for each, right? So then I can also, yeah, I mean, we'll delete this at the end. So this causes traffic to the service being equally split between our pods. And I guess because we want a bit YOLO, let's delete these. kubectl delete, yeah. RC size. Delete all pods. I guess we went a bit YOLO with that. But yeah, I guess that's one thing that's interesting is that like I still find it hard. Like I'm still having trouble figuring out like if I actually had a small app that I wanted to basically scale up in this way, like what would I do exactly? But I do appreciate the idea you can just like scale stuff. So port forwarding, okay. So with port forwarding, this is something Docker has very nicely as well. So you want to say, okay, well, I want to forward calls to port 80 to port 9876, for example. So they want to access the simple service from the local environment on port 8080. Okay, health checks. Okay, let's take a look at this. Okay, so they call it a liveness probe that has initial delay, a period in seconds, and then where it's going to get the health data, or at least expose it. Like, I guess this would expose it on a health URL at this port, and so you would basically call the service health 9876. So I think that sounds great. Let's do this. Say describe pod HC. It shows relevant sections. Yeah, so here, like this is all the liveness stuff. So now launch a bad pod, which will randomly in the time range 1 to 4 seconds, not return a 200 code. Okay. Now, so looking at the events, we can see that the health check failed. Health. In the bottom. I just add more colors, like successfully create container size failed. See, grep failed. Yeah, they're saying like liveness probe failed. Okay, sure. Okay. It also can be verified with the get pods command. The pod has been restarted multiple times because of the failing health check. So yeah, bad pod. Oh, I see. Yeah, I see the restarts now, like 10 seconds ago. So now it's gonna try starting it again. So what does this bad pod look like actually? I think we're gonna need to actually look at the Docker container as well. OpenShift Service Labs. Where's bad pod? So how do we, let's see, I need to just look at that pod and query the command it's doing. So wait, was it here? Health, info fail. Okay, I don't think this is it. I think it was some other file. Yeah, so let's say I want to get pod exec, and then I want to check bad pod. So kubectl exec kubectl pods kubectl pods. Oh, get pod, sorry. So we have bad pod. Did not expect the first thing I saw as I entered to be kubectl. Um, yeah, like it's like I will say that I'm an extreme noob, so this is gonna be purely for my own educational purposes. Probably not for everyone else's. I'm figuring out why this is useful. Uh, it feels useful, but it also feels complicated. But I also feel that's kind of a lazy excuse because lots of stuff is complicated. So I'm just trying to figure out what I should know about this sort of because I mean I'm pretty familiar with Docker at this point. Like I know enough to be dangerous, but not with Kubeflow. Okay, so kubectl bad pod. So I want to figure out what the hell's in this. No, but the pod. Can I log into the pod if it's failing? Probably not. I just want to see how it's failing because it's saying this returns like a random 200, like a non 200 error. Okay, so now this returns readiness after 10 seconds instead. Let's take a quick look at this. Kubernetes is, I mean, I think that's been everyone's experience with it, right? But like what isn't honestly like if like it sort of took me years to sort of have ML be obvious and not complicated. Same for like I don't know systems programming. Like you go to undergrad or whatever, and you learn all this dumb stuff. Um, so actually, yeah, like that's a good point because I think PyTorch serve has an integration with Kubeflow and MLflow. I haven't tried them actually. This is maybe the I guess more professional motivation to try this stuff more directly because I am one of the maintainers of TorchServe. But yeah, we'll see. It's not necessarily. I'm not necessarily doing this to try Kubeflow. I just want to know what the hell's up with Kubernetes. You know, like it's a more basic need than that. Like, okay, describe pod, fine. Okay, what about environment variable? We pass an environmental variable with this thing called simple version. Okay. Sure. This is exactly like Docker. Um, okay, and enter you can just print them all. Like you can just say, give me all the env variables. This is exactly like Docker. You can just set environment variables very easily, and then you can print them all. Print env is actually a Linux command. So in this case, you're just doing a shell, and you're getting this. Oh man, what is this? Guys, this is why installing NVIDIA library is super fun, right? I think this is what LD library path is, right? This is from before. Mandatory path. Ooh. What is all this trash? Windows path? What is LD default? I think LD library was a good thing. Oh, shared directories. After it's been successfully compiled and linked. Oh, okay. Okay, sure. So that's why I see it within. Okay, so I guess I've seen it within the CUDA context because it's probably calling a bunch of C++ libraries. Package lib, I see. Okay. Okay, let's keep going. So namespaces. As a workspace you're sharing with other users. So how do I set a namespace? So new kubectl. Kube node lease, Kube public, Kube system. Okay. What does this mean? No resource quota. Okay. What about Kube public? Kube system. Yeah, not very useful so far. Okay, namespace seems like not the most urgent thing for me. Okay, volume. So one thing I always found weird in Docker is that like volume sort of like essentially destroy the contract about this being a modular thing, right? Because it's dependent on a volume that may or may not change, right? And so the best you could do is isolate stuff by directory or whatever. Azure disk or GCE persistent disk. Interesting. Okay. Empty dir or home path, host path. File sharing types is NFS. Distributed file systems as Gluster and Cephas. I've never heard of these guys. What's cluster FS? Cloud storage and media streaming. Kubernetes nuts. Probably like an alias, I don't know, for get pods. What's Cephs? Multi-use performant file store for including shared home directories. A metadata pool and some journals. And what's an MDS? A metadata server. This reminds me quite a bit of BI systems. Like, I don't know if this is like a good analogy, but just like, I guess this is like distributed dimensions tables or something. It's probably not. No. It's a subject of numerous academic papers for its novel designs and contributions to file system research. It is the oldest storage interface in Ceph, and it was once the primary use case for Rados. Who invented this thing? Okay. What is this thing? So there's a volume that we're mounting called temp data. Okay, what's there? Is there anything there? Code temp data. Okay, there is not. And I guess it is a temp directory, right? So same for code temp exchange. I mean, what's in temp? Why am I looking at this? Juju. What is Juju? Okay, a bunch of empty files called Juju. Systemd private, some SSH stuff. GNOME. What's Juju? Okay, let's see. Juju. Oh, it is something it legit looks like. Juju. OpenStack at scale. On reducing on the operation overhead of software by facilitating deploying, and it's something the developer is canonical. Oh, okay. Everything is a file, by the way. So my girlfriend's in databases, and I just tell her, like, why do we need databases, right? We have files, and then you just have grep, right? Like why would you ever need to select from anything or just run a SQL query? All you need to do is grep. I am half trolling because I think when I tried SQL in Google Cloud, I actually really enjoyed it because it was sort of like, oh, like someone else like someone else figured out how to manage this system, and all I need to do is like punch in a couple of commands, and then I just get a bunch of data back, and I'm happy. So the volume should be only on the pod, right? No, so I think the way it works is that it needs to map to something on your local file system, is my understanding. But let's see if I'm wrong. At least within Docker, like if you can share a local volume. But I don't know if this is a local or a remote volume. So let's just see. Okay, so we created share vol, and then let's say, okay, I want to describe this thing. And then, so it mounted temp data for exchange, and var run secrets Kubernetes IO service account. cd code var run secrets. Okay, they're not here. Like none of these guys are here. But we connect to one of the containers in the pod to view the volume mount and some data. Oh, we can actually connect to it. So if you say kubectl exec it. Oh, it's exactly like Docker, by the way. I think the I stands for interactive. So what does -t stand for? -t Docker. Docker dash t CLI dash t Docker dash t. It's a man. Okay, whatever. So okay, we have ls. Okay, cool. We see the temp. Okay, so this is the exchange thing that we saw earlier. If I ran on a cluster, it would be really weird to expect to have a volume on the worker. All right, but what is this volume, right? Like you're creating a container, and this container by default has no disk. Like it needs to have some disk, and so it feels to me like by default there is a volume, right? It's just the remote directory. Allocate the sudo tty. Okay, bash. So the volume is mounted like any other file system. So, if I say, I see, like mount. Sorry, I'm gonna say mount. Oh yeah, you see, like there's all these like fucking, whatever these are, C groups. I think C groups is the core tech behind containers, right? Like, I think this is what I remember. It's also, I think, just restricting certain files and processes, which are also files. Everything's a file. That's just me being a neckbeard without a beard. But the grep exchange. Okay, dev SDA. Okay. So create a file amount that will be able to access from the other container in the pod. Ooh. Oh, I see. Or that's interesting actually. Like it's either persist between runs or persist between containers so that they can talk to each other. But talking via a file doesn't seem like the smartest thing to do, because I think what they already, like, they can already communicate to each other, and we saw this in some earlier examples, just via like yeah, so I'm going to say echo some data, temp exchange data, and this is the connection of the container. Wait a minute. cd temp data. Oh, I see. Data. Code data. Oh, sorry. There's no code. Code data. Yeah, cat data. Interesting. So we connected the container C2. So why is it called C2? I guess that's just the name in the YAML file, I would imagine. Let's double check. Yeah, there it is. So there's two containers, one called C1, one called C2. And then try to open VS Code in TTY. I think you can do that actually with Docker. That's what this thing is about. So let's say you have this container. Actually, fuck it, I'll show you. Okay, let's start this thing. You go to files, you go to boot. Actually, no, there was an easier way to do this. So open, no. Files, boot. There was an easy way to do this. It was like a, where was it? View logs, attach shell, inspect. Very fancy stuff. I think persistent volumes have the capacity to share data between pods. Yeah, so I think that's something we just confirmed. Because here it was between containers. You're saying it could also work between pods. That's interesting. Oh, and then pods means that the containers have network access to each other. But still, like I would imagine you would still have some sort of like load balancing IP at the front of a pod to make pods talk to each other. It just feels very bizarre to me to use disk to communicate with each other. Like there's no way the latencies will be acceptable for that. Okay, so what was this again? So there's this final. Okay, let's go here inside. So go to dev, huge pages, AutoFS. Oh yeah, so sorry. You see this, guys? Here. So we need to just go to home somewhere. Yeah, this thing here. So this basically says like, okay, open it to the right, and this is actually what I've been using instead of, or just download. This is what I've personally been using instead of like SSHing into a Docker instance. Like I can just set it up and then just start it from here, and this shows everything I have. I have a lot of junk actually. What is this? Moxarufim final meta node. Oh yeah, I remember this. This is actually not the first time I've went through like Kubernetes tutorials too. Like that's the worst part about this exercise. You'd expect that I'm actually a domain expert at this point, but I am not. Okay, oh, there you are. Oh, Christian, so maybe this is what you were talking about, right? The persistent volumes. So create a file, mount it, okay. So what's a persistent volume? It's a cluster-wide resource that you can use to store data in a way that is persist beyond the lifetime of a pod. It's not backed by locally attached network storage on a worker, but by a network storage system such as EBS or NFS or a distributed file system like Ceph. EBS file system. Persistent storage device I can use as a file system for databases. SSL. Yeah, I don't know, but like I was actually asked at work if I should do like an Amazon certification. It's kind of like I couldn't bring myself to do it. Like I don't know, like I feel I should just do it. Like I think a lot of these classes are like, let me show you like the commands you can type in, you know, and then like let me show you like a whole bunch of commands, and you know it's like a week of typing in commands. Probably not great, but who knows? Like maybe it's Amazon. Maybe they did a better job. Who knows? Okay, persistent volume. Let's check what the hell this is about. So it's a persistent volume claim. Persistent volume reclaim policy recycle. Okay. Size, speed, Kubernetes pod where you mount as a volume. Okay. Actually, I think back to my... So let me give you guys my real motivation, actually. So I was writing the cloud section, and I wanted to shit talk Kubernetes. I've only used them with Kubeflow. They are tied to the cloud provider somehow. I see, yeah. Let's see. So I think, Christian, I'm curious then, because like your day job seems to be like quite a bit of like research engineering. Like I think you have sort of like an insane pace of coming up with your own libraries. Do you also do like ops stuff for your day job? And let's see. So tied to a cloud provider. So I think what are the things you need to worry about when you're doing Kube? So you need to like restart, make sure everything is green. You need to rescale. Look at logs and cry a lot. Okay. So funny enough about secrets, I'm not even sure how to share secrets properly in regular Linux. I'm embarrassed to say that. So create a file. I mean, you put them through a CLI, but what if it's actually needed in the codebase? I had this issue with my Discord bot, for example. Let's use a secret in a pod. Describe secrets. Okay, so it basically means when you're starting it, load the thing at runtime when you start the app. So how would this work with something like Heroku? Like let's say I'm building an app, oh, I would use like some sort of GitHub action or something like that. So like when I push, I load a file, but load it from where? Oh, from like another secret location? No, but that secret location needs to be in the code base. Like at some point, like a human needs to do this. So that's what I find funky about secret management. Oh, there's GitHub secrets. Let's take a look actually. New repository secret. Add secret. Okay, so you can only use secrets in a GitHub action, right? Probably. Yes, secret, large secret passphrase. But then, like, what if you don't use GitHub Actions? Then what if you're like use Heroku, for example? Like, let's see. So Heroku. Maybe some other time. I'm actually really hungry, so I want to finish this and then go grab a bite. Heroku secrets. Oh, it's the same shit, right? So instead of GitHub being aware of it, I would upload it in the Heroku CLI such that when I deploy my... Okay, I see. So you're just like uploading a secret, not when you're actually running your app. You just do it at some sort of prior time. Okay, makes sense, makes sense. This is kind of useful, actually. I should be doing this. I think because I did get complaints about this. Yo, thanks, Christian. Yeah, for sure. I'll see you tomorrow. I'll be sure to announce it like probably around like 11, I would say, that day. So I think it'll be super fun. See you tomorrow. Okay, logging. Okay. Log me cgen logs.f. So what did we really learn that was interesting here? So I think jobs was actually, so pseudomain is actually maybe you know here. So my understanding of when like people have used Kubernetes quite a bit in terms of ML is they use it as a way to deploy, like let's say a training job. So you deploy a training job as a Kubernetes job, and then it runs on your infrastructure and it figures out like how to schedule the jobs and where you're gonna get the logs and stuff like that. So I'm thinking like my question is more around like let's say you want to build an ML deployment infrastructure where people write Python scripts, and those Python scripts may or may not use GPUs. And then you want to deploy them to some available hardware that you have. Like, let's say I have 10 computers here behind me. Now what, right? Like, so that's sort of, I guess, the problem I'm interested in solving here. Like, what would a deployment infrastructure look like for people outside of large companies? So in terms of deployment infra, I think you have the deployment and replicas. You have the service, labels, environment variables, and namespaces, volumes to talk between in a pod, persistent volumes for interpod, logging by default, and then we have jobs and nodes. I mean, it would literally be, right? Like you would, instead of saying bin bash, you would say Python, the training script, right? This is starting to make a bit of sense, actually. Okay, so this is, um, so this is gonna supervise a pod counting from 9 to 1. Okay. Oh, and then you would basically save the model weights to a persistent volume. It is like GitHub Actions, right? Like in terms that it abstracts the stuff away from you with a DSL. So let's think a bit about model training versus inference. So let's say I'm doing training. So I have a script that I wrote and I tested it out locally. And then I need to make sure that the script works in some sort of Docker container, which will have like my requirements.txt, my Python file, maybe some other related files. When the pod starts, it's going to run like Python, the training file, and maybe pass in as command line arguments everything I need. It's going to do the training. It's going to log some data to some persistent volume. It's also going to log the weights in a persistent volume. And then give me a link to where it was saved in the logs. That way I can then use the model for an inference, for example, and like push that model to another service that would be loading that model and then running an inference service where you're basically listening in to some requests and then sending those requests back to some endpoint. Oh, I see. Okay, this makes a lot of sense now. Okay, this is good. Okay, this is great. This is good. Okay, what are nodes then? So these are the machines where your nodes run, and yeah, so that's what I figured. As a user, you don't need to be aware of these. But that's the one thing I'm curious about is like Kubernetes GPU access. Yeah, okay. So you're basically setting it in limits here, right? So this is exactly what I expected. And I think persistent volumes just seem to be like a good way to save data for later because like the pods may be torn down, but once you want them to be checkpointing stuff, and maybe, I don't know, you have credentials that are also being loaded, right? So let's say your AWS credentials or whatever. Credentials loaded. So I think the big unknown I have so far that maybe I'll clarify in another episode is how do we basically build services where pods talk to each other? Because I think in the case of ML, they don't really need to talk to each other, or at least they just need to talk to one thing back. Like I call you, you give me an inference, or I tell you start running these jobs. Don't send me back anything, just log stuff and then write it to a persistent volume. Because I mean, let's think about this problem a bit, right? So, but then where are you submitting the job, right? So then, if you wrote a script, well, because like if you run the deploy command, so you would deploy the command, and then you have access to some sort of cluster that's shared among everyone, right? So what does a cloud shared cluster look like? Cloud shared cluster. Okay, I think we're good, boys. I think this was actually surprisingly informative. I thought we wouldn't get nearly this far. But I think what I'll take away from this is that so here's another thing, like with replica sets. Like I mean, I guess for ML, you wouldn't want to build replicas, right? Because you would rather do data parallel training. Like given the choice between, you could just have like multiple workers. No, so for inference, you would want replicas. For training, you would want data parallel training. So you would also want replicas. But then all of those replicas would, like, let's say, send their gradients to some central server. that then aggregates them. So maybe I think what we could do is talk a bit more about what does distributed data parallel look like in Kubernetes. And then how do elastic inference deployments work? And then basically a job, a submission, a UI to some central server. All right. I think this was great, folks. Thank you so much. I am probably, let's see, so let me make this a bit bigger. I can talk to y'all. So yeah, I mean, this has actually been surprisingly informative for me. So I hope you all learned as much as I did. I didn't do a nice recording of this. So I'll probably just maybe export the Twitch one for now, and then yeah, like I said, so tomorrow I'm talking to Christian, so it's gonna be, I guess, much more of a typical ML stream. But I guess now I feel like maybe we're getting close to what's interesting about Kubernetes, and maybe in a future episode, we could talk a bit more about like either a distributed data parallelism or a job submission guideline using all of these ideas. I think the main ones seem to be like creating a service with replicas and persistent volumes and logging and jobs. I think all of these concepts make tons of sense. So yeah, we'll be talking about that. Thank you so much, folks. I really appreciate it.